which is triangle congruence still. Let's talk about what we did yesterday really briefly. So yesterday, do we remember how we tried to say that these triangles were congruent? We had to list all 3 pairs of congruent sides, all 3 pairs of congruent angles. It was a lot of work, right? So now today I'm going to get to show you 4 shortcuts so that we don't have to list out all 6 pieces that are congruent every single time. That's what we're doing today. So those 4 shortcuts go by these abbreviations. They're little acronyms that tell us like the pieces that they require. So SSS, SAS, ASA, and AAS. Those are our 4 options that we are going to use. This is a very important table. We do need to know all of the things in this table, so maybe give it a highlight. And we're going to start with our first one. Very straightforward. It states that if I know SSS, side, 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 all 3 sides of a pair of triangles are congruent to each other, then the triangles must be congruent to each other. So this basically skips out all of the angle stuff that we did yesterday. We're able to say, as long as I know all 3 sides are congruent, all 3 angles must also be congruent because the triangles are congruent. That's what that says. Do you see that? I like to color code this because you will always have 3 different corresponding parts here. So I have a side, and another side. That's all this says. Questions on that? So from this, like once we have that these 2 triangles are congruent by one of these methods, then we're going to keep doing what we were doing yesterday and say something like triangle ABC is congruent to triangle. We want to make sure that we're lining up pieces. I believe this one goes XYZ. Remember what I said about lining up the pieces, making sure that we're looking at the tick marks. A is between a green and a blue, so X is between a green and a blue. We line those pieces up. All right, that's number 1. The next one we're going to see is called SAS. Again, those letters are representing the pieces that it needs. So for SAS, we need 2 sides and an angle. However, the order does matter here. So when I look at my 2 sides, I have CB and ZY, and I have CA and ZX. And then here in this definition, it is very specific. It needs an included angle. When I say included angle, and we're going to talk about included sides as well, that means it's like a sandwich. So it's like a side, angle, side, sandwich in that order. What I recommend you do when we have 2 angles and a side is literally highlight the 2 angles, or sorry, the 2 sides in this case. And then do we see how that angle here in blue that I'm going to draw is literally like wedged in between those 2 sides? That is what I mean by an included angle. Okay, that word included means sandwiched, means wedged in between there. SAS only works if I have that sandwich. If I had another angle, like let's say I had angle A and angle X instead, we can hopefully see that that sandwich no longer sandwiches that angle, right? That angle isn't wedged in there. Do we see the difference? So that we could not use side angle side for. So only because we have these 2 angles, C and Z, can we use SAS. Any questions on that? That's going to be a big topic for this whole unit, is that included angle. We also have an included side. I think included side is a little bit easier to see. So when I'm talking about ASA, it's like the same thing, but in reverse. I have 2 angles, and they sandwich together a side. So I have angle C and F. I have angles A and D. And then they sandwich this side AC and this side DF. Again, we call that the included side. It's wedged up in there between those 2 angles. So ASA has to be in that order, angle, side, angle. That's going to be probably the trickiest idea to wrap our heads around this unit, I'm telling you right now. Any questions on that? Okay. The last one that we have is AAS. So this is where we have an angle, and a non-included side. So this does work, where I have angle K and angle U congruent. I have angles M and S congruent, and then not wedged in between them, I have this side KL, and this diagram is actually drawn wrong. It should be this side TU. These guys are congruent. Ignore this guy. This guy's not congruent. Okay, but do we see how that side is not included? It's not wedged in between there. In this case, it's fine. Angle, side is one of our reasons that we can use. However, let's talk about the reasons that we can't use. So I'm going to go up to the top here. One of the reasons that we can't use, I'm going to draw an angry face here. One of the reasons we can't use is angle, angle. We cannot use 3 congruent angles to prove that triangles are congruent. So if I have 2 triangles, even if all of their angles are labeled nicely like this for me, I cannot use that to prove that these 2 triangles are congruent. I don't know about their side lengths. They could have vastly different side lengths for all I know. The other one, and this one I hope sticks in your brain, I'm going to draw a big sad face because this is the one that I see the most often. You're going to laugh. It's ASS. We cannot use ASS. We have AAS, that's 2 angles and a non-included side. ASS is 2 sides and a non-included angle. We can never use this, okay? So if our angle is not sandwiched in between 2 sides, we have ASS and is not going to work for us. So let's draw out what that kind of looks like maybe. So again, I have 2 sides. Here's a side, here's a side, and the non-included angle would be something like up here. Does not work for us. Cannot do it. I'm hoping because it's a silly word that it sticks in your brain as a naughty thing. We cannot use it. Good? Questions? Okay. So we have 4 reasons that we are going to be able to use to prove triangles are congruent. So let's take a look at these. From the information given in the diagram, can you prove that the 2 triangles are congruent? We're going to explain. So in example 1, what I recommend that we do for the first part here is we list out our 4 reasons. So our 4 reasons are SSS, SAS, ASA, and AAS. In your homework, maybe not today, but in the future, you will also see NP, which just stands for not possible. Okay, so if you see NP, that means not possible. And we're going to try to figure out what information do we have. We're going to count up how many pairs of congruent sides, how many pairs of congruent angles, do a little bit of process of elimination to start off with. So I have given to me A, B, and C, D are congruent. That's 1 pair of sides. I have a pair of angles. Remember, we have to be a little bit specific when we name our angles, especially when there's more than 1 angle involved here. So I would say that this is like angle BAC and angle DCA are congruent. So there's a pair of angles that is given to me. Then I have to take a look at what else do I have? Because it's not always going to be given to me. Do I see in this diagram something that's not marked, but something that we definitely know is congruent? Caitlin? What other side? This one? Is that the one you're talking about? Yeah. Yeah, that's congruent to itself. Remember, we have the reflexive property to tell me that something is congruent to itself. So I don't have that marked, but I can easily find that. The reflexive property is one of like the big 3 things that we should always be looking for. I'll show you what the other ones are. So I also have another side. Now, just because I have side angle side, that doesn't mean that I have SAS. it does mean that I can eliminate the other possibilities. It's not SSS, it's not ASA, it's not AAS. We have to make sure, before we go ahead and circle SAS, that we have two sides sandwiching an angle. Do we have that in this example? Yes, we see that wedged in there, so I can circle SAS. Yes, these are congruent. Let's do it again in number 2. I'm not gonna do this every time, but for right now, let's just list them all out. I know I have SSS, SAS, ASA, AAS, or not possible. I'm going to start with my givens. I have a side, I have an angle, and I have another side. We see all those are given to me, right? That tells me I can do a little bit of process of elimination. Oops, I didn't write that in. Little process of elimination. I know it can't be SSS, can't be ASA, can't be AAS. But I have to double check and make sure that those two sides sandwich in that angle. So I highlight them. Is that angle sandwiched this time? No, it is not. So I cannot say SAS. This is not possible. No, we cannot say these two triangles are congruent because we cannot use ASS. Sad face. I'm hoping that sticks in your brain. I know it's silly, right? Okay. We don't have to list those things out every single time. We can just kind of look at these things and try to figure it out ourselves. So let's take a look here. I have an angle. I have another angle. So currently I have A. What other piece do I have? Just like we did before in number 1, what was that hidden piece we had to look for? Yeah, the middle line. It's congruent to itself. That's reflexive again. Super common. We find reflexive stuff all the time. So AAS, I'm kind of in the middle here because I know that my options are either ASA or AAS. I'm going to pay attention to what order these are in. Are those two angles sandwiching in the side? No. So this must be AAS here. Questions on that? Okay, one more like this. Take a look at number 4. Ooh, blurry. I start with what I'm given. AE and DB. That's a side. I have EB and CB. That's another side. What else do I have in here? Casper. Vertical angles. So reflexive is one of our most common ones that we can find. Vertical angles, probably the second most common one that we can find. So I do have that pair of vertical angles right here. Vertical angles theorem. So now I got to pay attention. What order is this in? I have two sides and an angle. It's either AAS and that's naughty. It's ASS and that's naughty. Or it's SAS and that's totally fine. I highlight. Are these two things sandwiched? So are these two triangles congruent? No. Again, we have ASS and that is naughty and we can't use it. Any questions on that? Okay, flip it over. Now, when things are not possible in your homework today, it's going to ask you to provide something that would make it possible to use one of these reasons. So if I look at number 1, I'm going to first start with what I'm given. So I have this angle, this side, and I have another angle. That's all given to me. What I want to do, because I don't have enough information, is say what would make this ASA. Any ideas? I have a side and an angle, So to get ASA, I'm clearly looking for another pair of angles. What specific pair of angles do I need? Casper. Yeah, if I had angle A and angle D, I would be able to use ASA. So you need angle A congruent to angle D. I don't know why this is so squished together. Questions on that? Let's do it again. In number 2, I have a side. Oh, this is something that my first hour was not quite sure on. Do we remember what these arrows do? These arrows are not congruent tick marks. What do arrows mean, Casper? Parallel lines. So don't get confused by arrows. Arrows do not mean congruent, they mean parallel. So I have parallel lines. I also have an additional tick mark that does tell me those sides are congruent, but I have nothing else. So if I'm trying to prove this by AAS, I have to find a couple angles. There is one based on this diagram that I can find. Do we know what it is? We can use our parallel lines. And just like reflexive and vertical angles, this is our third reason that we are going to see all of the time. If I have parallel lines, it is reasonable to assume 95% of the time you are going to be able to find some kind of alternate interior angles. So that's how we get our second angle, or sorry, our first angle. Now, in order to use AAS, which other angle would need to be given to me? What do I need? AAS, Dahlia? Well, if I do L and G, do I have AAS or do I have ASA? Yes. So it can't be those two. It's got to be the other two. It's got to be this angle up here and this angle down here. If I had those, I would be able to use ASA because, pay attention, this side is not included in those two angles. So I would need, let's be a little specific here, angle LFK, where F is my vertex, is congruent to angle, making sure we're going in the right order here, GKF, where K is my vertex. Hello? There we go. Any questions on that? We're almost done, I promise. All right, let's do next. Now we're going to put it all together. This is like what your homework looks like. So I take a look at the diagram. I'm trying to figure out, are they congruent, yes or no? If they are congruent, to write a congruent statement for them. If they're not congruent, to provide a reason why they could be, like provide an extra example. So I have currently given to me a pair of sides, a second pair of sides, and I know F is a midpoint of EV. What is the significance of that sentence? What does that tell me in this diagram? Caitlin. Perfect. If F is the midpoint, then it must split this segment into two congruent segments. So that gives me my third side by the definition of a midpoint. So I clearly only have one option here. It kind of eliminates itself for me. This has to be SSS because I have 3 pairs of congruent sides. Now I'm going to write my triangle congruent statement. It really doesn't matter how we write the first one. Let's go with EJF. And now I have to line up the pieces. If I started with EJF, what do I call the second triangle? Remember, line up those colors, line up those tick marks, Casper. Perfect. Questions on that one? Okay. Number 2, QS bisects angle PQR. There's nothing else in this diagram marked for me. Let's take a look at what is the significance of this. What does that statement tell me about this diagram? This was tricky in first hour. Any ideas? Caitlin? Exactly. QS is this segment here. It's bisecting PQR. All that tells me is that this angle and this angle are congruent. It doesn't tell me anything about any segments. It doesn't tell me anything about these angles over here. That's still a big question mark for me. All I know is those two angles. Is there another piece that I can find in here? Ian? Perfect. SQ is congruent to itself. That's reflexive. Anything else? Do I have a third piece? I kind of go through my list. I used reflexive. Do I have any vertical angles? Do I have any parallel lines? Those are my most common three. I don't have any of that, and I can't just make something up. So this is an example of something not being possible. What would I need? There's 3 different ways we can do this. What would I need? I currently have an angle and a side. What could I use here to help me prove that these are congruent? If in a perfect world I had this, I could say these 2 triangles were congruent. There's 3 examples that are good. Give me one of them. Do we understand the question? Dahlia? Perfect. If I knew PQ and RQ were congruent, I could use side angle side. I could do a bunch of things. I could find another angle and I could use angle side angle, or I could use angle angle side. We don't have to list all of them. We just need one reason. Questions on that? Okay, one more. Let's talk about what I already have. I have a side. I have an angle. What else do I have in here? Casper? I have vertical angles here and here. So I know process of elimination can't be SSS, can't be SAS. Which one do I have, ASA or AAS? Casper? ASA. We see that side is sandwiched in between my 2 angles. So this is ASA. If I start with, let's go LMN. What's my other triangle? How would I name my other triangle if I go LMN? Casper? OPN. Perfect. Questions on this? Can I show you just a really quick little thingy over here? Flip to the next page. I'm going to go through this super fast. Why can we not use AAA and ASS? So first of all, if I draw a little triangle here, you can draw along with me if you would like to. And let's say I have the angles 90 degrees, so this is a right triangle, 60 degrees and 30 degrees. Those are my angles. Let's say I have another triangle that kind of looks the same with the same angles. Are these 2 triangles congruent? Even though they have all 3 angles, clearly these 2 triangles are not congruent. Clearly one is much bigger than the other. So that is why AAA doesn't work, because no matter what my angles are, my side lengths could always change. And then let's talk about SSA. I think they're cowards. I think they should just put ASS, to be honest with you. If I have this triangle, let's say it's 2 inches. Let's say that this is 1.75, and let's say this is like 40 degrees. I'm going to draw the exact same triangle over here. Well, that was kind of wobbly, but it's fine. I want to say that these 2 triangles are congruent by side, angle, or that angle is not included. So what I'm going to do is I'm going to erase, I didn't mean to do that actually. Let's keep that, but now let's swing this 1.75 side this way. I still want it to be the same length. I still want it to be 1.75, but do you see how it's kind of like swung outwards this way? Same length, we swung it out. Now is this side still the same length that it was before? I still have that two sides. I still have that angle, but this bottom side, not the same. So that's why we can't use ASS. That's it, in case you want to know. Any questions on this lesson? You feel like we got it in the bag?